Hi, everybody. Welcome
I
again to the third or the fourth episode that we're recording. And we saw a lot of comments on the past ones. You guys, thank you. Keep the comments coming. Let's share your thoughts. Tell me what you think. Really love to hear from you. On that note, we have so this will be the last episode of the DevOps Wahala series. So just a side note there that coming the next episodes will have something very exciting for you. I won't give you the topic yet. When you wait till the end, you will find the new episode, the new season in quotes at the
on a
end of
series.
this record. Yes, series ahead. Sorry, I said season. So watch till the end if you want to find out what we'll be talking about, in the coming episodes. On that note, today we're talking about
Drum rolls, drum rolls.
who touched the pipe. Drum roll. Who touched the pipeline? It's not me. Oh. Who touched the pipeline? DevOps blame games and broken CI/CDs. So this is all about something we've seen time and again. When everybody asks you, did you change something on the pipeline? Say, no, it's not me. I did not touch it. And then they go and check the Git history and they see that you're the one that pushed the last
It's
commit.
probably
So that's what we're talking about today. Usual, as usual, if you have any stories, you want to share anything, you're always welcome. Drop it in the comments, reach out to us personally or otherwise. So let's start. Who touched the pipeline? What is even most painful is that why is it when you have a presentation or maybe you're in stand up and you're trying to show, okay, this is what we have now, this and then all of a sudden you try to run the pipeline, something that has been green ever, like it's green, all of a sudden you just see red, and then you're wondering what happened. This thing was working 2 hours ago, this thing was working 1 hour ago, what changed? Who touched anything? And then here goes everybody saying, I didn't touch it. It wasn't me.
yeah, yeah, I
It's
get
always
it.
very painful. But it's also something that we need to talk about because when it's not like you're working with demons, somebody definitely touched it. Something definitely changed. So
Mhm.
those are some of the things that we'll be talking about today.
I think most often than not, if an automated process starts failing, then certainly you are sure that somebody touched it. So either by commit, either by doing something they're not supposed to do, changing environment variables, something has changed somewhere. Right. So I mean, throughout the course of this conversation, we'll be talking about what the usual suspects are, things you should look out for, how we can prevent this thing in the future, how do we even handle these situations when they arise? How
Mm-hmm.
do That's DevOps culture. How do we point fingers? Do we not point fingers and things like that? So I think I can kick it off by talking about what the usual suspects are when it comes to pipelines failing, demos failing, something that has always been working suddenly stops working. I think one major corporate, or one major thing you need to watch out for is bad commits. And this could be from developers, this could be from DevOps engineers. If someone makes a commit that is not, in quote, now a good commit to a working system or a working process or a working
Mm-hmm.
pipeline, there's a
Mm-hmm.
probability that something might happen. So that's one key thing that we need to watch out for. So I will praise the. I think we can just do one alternatively, and then let's see how many we can mention.
Okay. So there are four main pillars or four anchor points, if you may, that we want to talk about today as one of the common causes. So, like we would not just tell you, oh, this is what is wrong without giving you solution. So we will tell you what we think is wrong or what the usual suspects are, and then what you can do better. Now, starting up the first culprit, the mama of everything is pipeline reliability. Is your pipeline reliable? Can you like The one that even used to pain me the most is that at least if your pipeline wants to break, let it break with dignity. Not the one that it will be one stupid small error that would break your pipeline, and then everybody is a at least if you want to break, break very well. Let them know that you know. So pipeline reliability is a very big one, right? And why can you say that maybe your pipeline is not reliable or something? Maybe you have just one massive. You see some pipelines, you'll see maybe 100 lines of YAML of code in a YAML file, and that 100 line is controlling everything. So even if anything changes, you don't even know what changed, or if anybody changed everything, because you just have one massive file. That is on so many levels can be better. I won't say it is wrong, because there is no wrong or right way. They're just, other ways of doing things. But it can definitely be better. Or you have tests. When you're trying to build a pipeline and you're trying to write tests, and you just put the test like, may not be say I did not put test. And then even you yourself, you're not confident of the tests that you put in your pipeline. That's very wrong. Don't do that. Because then if your tests are flaky and it's just there, your pipeline will not run. Let's say you have a pipeline that you maybe wrote your CI/CD pipeline for a deployment of a node app. Now I would assume that you would have tests, linting configurations and all those sort of things in your pipeline. Now if you want to deploy the same app for maybe Java, to an extent, maybe 70% of the code is Java. That means that you also have to adapt, this pipeline that you have to this new um programming language that you have. Not like you're writing code or do this one unit test. No, not necessarily. You can, but not necessarily. But you can have maybe a linting test that is looking for node code to run on a Java code. Of course, that would show on the pipeline and it will show as red. It might not break it, which is where people feel like, but the pipeline didn't break, so it's fine. But that's not how you know that your pipeline is reliable. It doesn't have to break like um let's break finish, like, do you get? It doesn't have to break before you see that it is wrong. All those small when it looks like you slap a bandage over something and everybody sees these errors in the pipeline, but everybody's used to seeing these errors, so whenever it comes up they just say don't worry, just ignore it. That's not right. Make sure that your pipeline is as reliable as can be, and don't just use a bandage to cover what the real issue might be, so that's something. And what can you do? I said something about having like a long YAML file. That can be better. You can break it into modular steps. Instead of having just one long file that does everything, why not break it into smaller steps? A part of the pipeline that does the build, a part of the pipeline that does the testing, a part of the pipeline that does the deployment. Separate these things. A part of the pipeline that does the test. So that whenever there is something breaking in the build stage, you already know where you're going to, and you're working with a smaller configuration to fix in that space. Do you understand? So that's something that you can do. It will still end up giving you maybe a long YAML file, but in this case, everything is modular, so you can manage them independently of the other step. And that way, it will be harder for you to slap a bandage on top of it, because then, if this fails, then the whole pipeline fails. You get, you won't put conditional biases and say, oh, let it just pass, we'll come back to it later, that sort of thing. So that's one step. Another thing, before I hand over to you, would be to use templates or shared steps. When you work in an organization where you prioritize um, 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 you prioritize repetition of code, that sort of thing, it is easy for you to be able to share templates. So, like I said, in the example where I gave, where you have a node, he's always smiling because he said I've hijacked the podcast. Anyways, but guys, so if you have in the example that I gave, where you have, the node, you have a pipeline for node deployment, and then you have another pipeline for Java deployment. Now, in that case, I mentioned previously that 70% of the code could be reusable. Now, why do you want to always copy, 70 lines, let's say 70 lines of code across all the different environments? Why not make that into a small template and then reuse it across, all these the repeatable ones that that are standard across whatever programming language, make it into a template, reuse it. So that way, if nothing is changing on the template, then you know that you just have to configure in quotes your pipeline to use that template. And because it's something that you've used over time, you can always improve on it in one place. So not that your node pipeline is the most up to date and then your Java pipeline is still flaky because of it. And you have the updates. It's just that because you have it in chunks in so many several places, it's harder. You know that sort of thing. So why not have templates, shared templates that you can share? I think GitHub CI, is it GitHub CI now or GitHub Actions? They have one of the best reusable templates that I've seen so far. That's based on the tools that I use on a regular, right? I may be wrong. Maybe there are more you can share with me. We're open to learn. So I did not hijack the podcast, but yeah, continue.
Thank you very much, Prince. I think you mentioned very critical points. Um, I will just add a few, and then we can move to the next section of the conversation.
Mm-hmm.
Like I mentioned earlier, bad commits. I also think you've also touched upon that. Basically, bad commits, like I said, doesn't necessarily have to be software engineers. Those engineers too can make big bad commits to the code, to the pipeline, and that could cause a failing pipeline. I think I'll just mention two things. One is secrets or credentials or environment variables. This a change in secrets or environment variables or credentials in the pipeline could also strongly cause your pipeline to suddenly fail. A pipeline that's always been passing, you decide to change a secret or add a new secret or remove a new secret, remove old secret, depending on the configuration of your pipeline, this could break your pipeline. And then one last thing I wanted to mention about usual suspects for failing pipelines is what we talked about last week, which is it works on my machine and not in prod. This it works on my machine syndrome could also be a strong indication for issues in your pipeline. So, for instance, you have a certain way your pipeline is configured or your code is configured on your machine, and then when you go into the pipeline, the build environment is different, or the way things are done in the pipeline is different. This could also cause pipeline that is already working to also stop working. So yeah, I think now we can move to other things that we want to talk about in relation to this topic.
Okay. Okay. So Ido has finished up. See, me and Ido, we're a very good team. At this point, it's as if we are finishing up each other's sentences. I mean, what's that thing that people always say? Anyways, the second anchor that we think is very, very crucial is access control. We see situations where once you join the dev team, which is good, which could be good or could be better, where you join the DevOps team and maybe in GitHub there is already a group, maybe the DevOps group, and then you join the DevOps team and they add you to this group. And let's say the DevOps team has admin access to all the pipelines, to all of these things. And so by virtue of you being in that group, you automatically have admin access. Now, that could be a good thing or a bad thing because then if you want to give access to one person on the team or to a project, you don't have to do it individually for everybody. You can just do it to the group and say, oh, I want to give access to XYZ project to the DevOps team. And then you just do it in one click and that's all. But where that is bad is because then too many people have access to your source code, to your pipeline in this case. And like typical Yoruba people that they will say that too many, okay, maybe it's not a Yoruba thing, so they will say too many cooks spoil fruits. I mean, I don't know why I just thought it was a Yoruba saying, sorry. But too many cooks spoil the broth. In this case, where too many people have access to the pipeline, to the source code, it could be a problem because that is where, if there are 14 people in the DevOps team and then something breaks, and then you're asking, who touched it? There are 14 people that could have touched it.
Yeah.
Do you understand? So that's a good thing, a bad thing at the same time. So that's something. Not everybody should have access. That's just the honest truth.
Okay,
I'm already buffering in my head.
talking about access, I think when it comes to identity management, authorization, authentication, these are the
Mm-hmm.
pillars of what DevOps is all about. As a DevOps engineer, you should be able to know who has access to what, and to what extent they have access, right? Because if you don't know, then
Yeah,
you're flying blind, right? You don't know who is
true.
changing what. You don't know if this is not. You don't know if this is even an attacker, right? So one of the fundamental bases or pillars for DevOps is access control, identity management,
Mm-hmm.
organization, things like this. So, and this also applies to this conversation we're having when it comes to pipeline. As a DevOps engineer, it's a necessity to know who should have access to this pipeline and at what level. So
Principle of least privilege. Principle of
yeah,
least
yeah,
privilege.
yeah, exactly. Right. Who should have access to this pipeline? And if you have access, what should you be able to do? Right. So for instance,
Mm-hmm.
should you be able to change secrets? Should you be able to change environment variables? Should you be able to manually override the pipeline? Should you be able to like all these things need to be in place? And I
Mm-hmm.
think we can talk more about this when we talk about DevOps culture in a couple of minutes. But this this needs to be in place. But however, just to add to access control, I also think that um, this role-based access platform that you mentioned, when it comes to CI/CD pipe environments, the same way you cannot give everybody individual access, it's stressful. Having a role-based access control
Mm-hmm.
principle or culture in the company would help a lot, where you know that,
Mm-hmm.
oh, for example, you can say all junior engineers should have this kind of access, engineering managers should have this kind of access because they'll be able to build
Mm-hmm.
competence and
Mm-hmm.
trustworthiness over the years. So you know that in most cases, often than
Mm-hmm.
not, a junior engineer is more prone to mistakes than maybe an engineering manager. It's not always the case, but in some cases, in most cases, it's just so you can use
Mm-hmm.
that to actually maintain the role-based access and then give people just the permission they need to do their job. Now, I would usher us into the next section, which is observability,
Wait
right?
now, before you usher, I want
Okay,
to
go on.
say, I want to add one thing.
Uh,
To so one thing I wanted to add before Idowu talks about the next topic is most people, or something that we've seen over time, is that most people they treat sorry, not observability, they treat the pipeline stage as the end, like as something that is not as serious, not something that is not as important. They see it as, okay, the devs have done the great work of writing the code, now the pipeline is just to, finish. It's not always the case. The pipeline is equally as important as the source code it is deploying. So that's why people treat it, or most DevOps engineers treat it like, it's just at the end now, it's just to deploy the hard work. So they don't put so much attention into it, and that is wrong. Like it was mentioned previously about, commenting secrets, putting your secrets in the pipeline. If you expose your pipeline that way, an attacker can use your pipeline to access your source code. So if your pipeline is not well protected, then you are just as easily exposing the source code in this case. So it is not an afterthought. Your pipeline is not an afterthought. It is something that is very important, and people should take it very, very seriously. So nobody should just be able to make an update to the pipeline and push it without any review. No, it should go through the same process. You write, you have the pipeline, it is reviewed appropriately, and then if everybody agrees, there is a sign off on it, and then you can now start using it in your deployment, which would also mean that you have tested whatever changes it is in your pipeline. So it's not one junior dev. Sorry to the junior devs, but it's not one person just coming and then making a change on the pipeline, pushing to main, and then it breaks the entire thing because there is no source code, software development life cycle in the pipeline process. It should be, because it is equally as important. So back to you though, as it takes us into the next, anchor point.
I think the next section is observability when it comes
Mhm.
to broken pipeline. I think one bad thing that can happen to those engineers is to be blind when something is wrong.
Yeah.
That you don't know, like it's bad enough that something is bad, or it's crazy enough that something is bad, and it's worse that you don't know about it, right? Or you cannot even identify
Hmm.
where the problem is coming from. So, and that's why we're talking. We're also adding observability. I mean, if you see the trend in the topics we've been talking about, you will see that observability is very key when it comes to DevOps. You need to have your
Yeah.
eyes. You need to know when something is wrong almost immediately, right? And that's the same case when it comes to um, pipelines, right? When it comes to your pipeline, you need to be able to know when something is wrong. You need to be able to know when a stage in your pipeline has failed. You need to be able to know what stage failed. You need to be able to know why it has failed, right? And this also ties to configuring proper alerting in your pipeline. So in most cases, what I see companies do is from their pipeline, they have a Slack, they have a notification to their Slack. So when a stage fails, it updates the engineers on Slack. So that's a quick way to know when something is wrong. Another thing you I think you ought to do is to have logs, right? When the pipeline fails, when the stage fails, there should be proper logging to know why it has failed, right? Is it an internet connection issue? Is it a Docker build fail? Is it you need to know why it has failed? Um, then and another thing you can also look at is you properly monitoring your pipeline, right? Now, monitoring when it comes to pipeline can be a bit tricky in the sense that you
Hmm.
need to know for instance, if there's a spike in how many builds you're doing, so if on an average day you do 10 builds per day, and on a weird day you're saying 10,000 builds, you know that something is wrong. You know that probably somebody is using your pipeline for something other than what it is intended to. So all these things you need to, when it comes to observability, you need to monitor your pipeline as so your pipeline is as important as your code, right? You need to also monitor your pipeline the way you would have monitored your code so that because your pipeline is basically the gateway into deploying your code to production. So you need to also protect it
Hmm.
and monitor it as effectively as possible. So great.
See, it all said that you should have your logs, Abby. You should log and you should keep your logs. The biggest self-sabotage that we've seen is when you have the logs. You have it all. It's not that you don't have it, but it's not readable. Nobody can read what your logs are saying. It's not human readable. There are a lot of it's messy. So it's not enough for you to just have logs. Make sure that your logs are human readable and it's not just a bunch of junk that is together that okay, something is going wrong, and then you have the logs, but you can't make any sense of what it is. So that's a problem. Another thing is that um sorry. Another thing is that one problem that I've seen when you have the logs, let's assume you have the logs and the logs are even readable, like everything is good, life is good. You now see in the log they're saying step one, step two, step three, and then you're trying to debug, and it's a mental struggle for you to keep wondering, okay, what is step two? Step two is build, step one is this, oh, step three is deploy. Name your processes. It's very, very important. It will save you time if you're debugging. And aside from saving you time, it just makes it visible for everybody that comes to see. So if this is a stage that builds the end-to-end testing, put it there, name it properly. So if anybody just says, oh, let me see your pipeline, they can take a look at it and sort of understand what processes you're running and what is being done. Don't just say step one, step two, stage one, stage two, and then when everything you're now troubleshooting, you have to keep going back to the code to look, okay, what is stage two, step two of stage two doing? No, that is not right. So please name appropriately. And the one that used to bust my head the most, the pipeline is green on the outside, but it is still broken inside. Like people would let me not say people, I can be people too, but I would not admit to anything where you would you would upcode it in a way such that it
It's
shows up
always
as
perfect.
green.
It
pass. Like
always it will always pass.
it always pass, even if the conditions are not true. There's no bigger self sabotage than that. Why are you doing that? If your look at it again, look at where whatever is going wrong and try to fix it, right? So it's not okay for it to just look green. Now everything is green. Go into the logs and see, what your logs are saying. And it's good because in this day and age, there are a lot of tools that you can use to monitor your builds that are not expensive. Some of them are even open source. There's Datadog, there's Grafana, there's Prometheus, there are your CI/CD dashboards. You can use all of these tools to, at one glance, see what is failing, see the logs, know how to, move forward from there. So please, it is very important. Ido also mentioned that Latin. Somebody should not just stumble on your pipeline failing. So it should not just be something that you just stumble on. Alert. If something is going wrong, if there has been maybe one failure in the last 1 minute or 2 minutes or whatever your configuration might be, let it notify you. That is why you're a DevOps or you're an automations engineer. You need to be able to tell something when it has happened. Let it not be that it's the dev team or the QA team that is coming to come and tell you, your pipeline is red, or is this. No, because it has been working fine for the past 1 year does not mean that you do not need alerting. Please, this is 2025. We should all be better engineers. And if you watch Cloud Chatter podcast, at the end of this 2025, your game, you should be A level, oh, you guys. So, do you want to talk about the last anchor point?
Yeah, sure. I think the last one is basically culture and how do you react? When it comes there was culture in the company, how do you react when these things happen? When for all of maybe there's a live deployment and pipelines are failing. So how do you react? How do you basically respond from a cultural perspective to something going wrong within the DevOps process? But I think one key foundation should be always have a blameless culture, right? When things go wrong, the goal is
Yeah.
not to find a way to point finger or find someone to hold responsible for the whole downfall of the pipeline. I think the goal is to be able to learn from what has happened and see how we can prevent it from happening in the future. And this is also where postmortem comes in, right? So when you have a blameless culture and you have postmortem,
Yeah.
the idea behind it is to first of all, something is wrong, try to fix it almost immediately. And then when you have fixed it, have a meeting to talk about what happened, how it was fixed, how it can be prevented in the future, and what are the action steps we need to take to make sure it doesn't happen again. Right? Having that psychological safety gives people the avenue or the opportunity to be able to try out things. And in trying out things, you can also ensure improvement in your process, introduction of new ideas. People are not too scared. They are conscious, but they are not too scared to try out new things so that if it goes wrong, they are not blamed. But that psychological safety is there to make sure that, oh, yes, I know I can try new things, even though I need to be as careful as possible. However, I still know that yes, I can do this. I can try, even though the pipeline fails. My goal is not to make sure the pipeline fails. My goal is to probably introduce a new thing, and then you are sure that you can comfortably communicate with your team members, and there's no blame involved. So, a blameless culture and postmortem, a combination of those two would make people will lead to improvement when it comes to the DevOps part of things, and people will not be too scared to try out new things. So, like I said earlier, the goal is not to point fingers. The goal is to learn from what has happened and see how we can, as a team, come together to ensure that it doesn't happen again in the future. So, for instance, say someone joins a new team, whether senior or junior in this case, joins a new team, and maybe first week on the job, they've broken the pipeline, 30 plus application to production. Now, a good action point could be putting things in place to make sure that that does not happen in the future. So a new member of the team, not having known how the process is done, should not be able to break a production pipeline. So things like that. So yeah, great.
Emphasis on blameless postmortems, because we've worked in organizations where they're having postmortems, oh, all well and good. But at the end of that postmortem, if you don't feel like dropping your resignation, that was
Good,
not
not good.
like blameless postmortems. This is not the time to point. Yeah, and this is even beyond pipeline outbreaks. This could extend to major incidents that could happen as
Mhm.
well in your career. Normalize, like, this is to the higher ups now. Let's normalize blameless postmortems. You don't get to point fingers, because it's not like my goal is to destroy your company or burn it to ashes or whatever, you know. And another thing is that people, like Ido said previously, people are always afraid of owning up to mistakes, because the last time a Shola, just a random name, if your name is Shola, sorry, the last time a Shola or an Ido owned
Wow.
up that they made they made this mistake, they were fired on the spot. So if that kind of thing happens, of course, if I make a mistake, I would not own up to it, and I could go great lengths to cover my track to make sure that you don't find out that it's me. So instead of me to spend more time doing the actual job and trying to make my processes better and more effective, I'm spending more time in making sure that you don't realize that the mistake came from me. That is a toxic culture, right? So please, let's make sure that people are able to own their mistakes and they're able to learn from it. Because you too, if you make mistake the first time, they pardon you. Second time, they pardon you. Third time, they pardon you. Are you the only one in the organization? If they are pardoning too much, to learn
Yeah, to
how to do your
be
work
more
better,
conscious.
or
Yeah,
go back to school if you need to. So as much as we want to say, own your mistakes, also make sure that you're learning from it, right?
yeah.
If you do something wrong now and you see the effect and it's not what you want, then go back to the drawing board. What did I do wrong? What can I do better? How can I make sure that this mistake does not repeat itself? Now, how can I make sure that this mistake does not repeat itself, not only for me now, but for anybody else, which is where documentation comes into place.
Mhm.
DevOps teams, right? We hate documentation so much. I'm saying we because it is something that you have to constantly, you know, make a mental process of that. I need to document this process. It is not nice that only you understand how the pipeline works. And then if anybody wants to know how the pipeline works, they have to do the rigor and go and start understanding, oh, why is this commented out? Oh, why is this here? What is this doing? Why do we have this type of testing instead of this type of testing? A document. Very simple. Why it's like writing down your thought process as you're building this pipeline, because you can build a pipeline and leave the company shortly afterwards, and then somebody wants to take over this project and they are wondering, why did we go with Datadog instead of going with maybe Prometheus or something? Maybe there was a business decision that influenced that choice at the time. If it's not documented, I can go ahead and switch without, and there could be consequences. So
Yeah,
documentation, very, very important. Please write it down. It doesn't have to be a fancy document, even though fancy documents are nice, and there are a lot of tools to help you with documentation these days.
yeah.
But make sure you write your thought process down for the next person, so
Mhm.
that a mistake that you made, that you have learned from, another person can learn from that same mistake just by reading what you wrote, without having to make the same mistakes themselves before they can learn from it. So please, it's very, 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 very important. And let's also encourage um a team-wide literacy of how. I've seen some DevOps engineers where they say, CICD, and me, I don't really know it all. It's not my strong suit, and then they just stay in that space. And so if there are issues with the pipeline, they just hands off, like, Me, who said is not my strong suit. What is that in 2025? Everybody, maybe, but everybody should learn these things, right? Learn, learn. This thing is not even hard. Just learn, study, go and read. It's literally that easy, And n- I don't.
I think is not too
But
good.
really,
I think it's not so good if as a DevOps engineer and you're saying, oh, I'm the Terraform guy, or I'm the Kubernetes
mhm,
guy, or I'm the Ansible guy, and when it comes to CI/CD, I think CI/CD is fundamental to what we are everything we are doing. So I don't think you can just say hands off. I wanted to say something when you were talking about blameless culture. And what I wanted to say is, it's
mhm,
easy. It's easy to talk about blameless culture when you are just an engineer, when you are maybe a junior engineer, a senior engineer, and you are just the engineer. I mean, because you are more prone to making the mistake than being on the other end of the mistake. However, when you are the engineering manager or the team lead or the whatever position it is called, it is less fun when you are handling a blameless culture because, like you said, if the same person is making mistake in 1 month, you have made like 10 mistakes, bro. Maybe we should blame you. So, so even if you operate a blameless culture, you should also be very conscious or very careful when you are making mistakes. I mean, only you cannot cause 5 production downtime in 1 month. So, what are you doing? I mean, so you also need to be careful. And also, talking about postmortem, I think if you are the cause of a downtime or a pipeline break or a production downtime, before the team wide postmortem, I think you yourself should do a personal postmortem. Right? Look at it, look at what you have done. Tell yourself the truth that you probably should have probably done something different. There's some cases where there's nothing you could have done. This thing will still happen. But there's some cases where maybe if you took another 2 seconds to look at your configuration before you ran it, maybe it will not be the case. So yeah, that's everything I have concerning DevOps culture when it comes to things breaking, blameless culture, postmortem, and things like
and wrap it up. And if after everything we have said, your pipeline is still breaking, maybe you should check yourself. Maybe your village people or is all going delay for Yoruba people that is after you. Just check yourself, please. And it's very important that you don't stop learning. You don't see, you are never, I know you might feel like you're at the peak of your career, but make sure that you always strive to learn something new. Maybe that template that you've inherited that has been used before you joined the company that your superior wrote or something, maybe it's due for a change. But how would you know if you're not learning new things yourself, right? So please make sure that you keep learning. And that will bring us to the end of this episode. And guys, I promised at the beginning that I was going to, tell you what the next episode, the next series. You said, is this?
that.
You shall get this. What it be about? And it is going to be the Zero to Hero series. It will be focused more on beginners, people that are trying to enter the DevOps space and much more. But a lot to come, you guys. You know that we are going to bring you great gist. You know that we are going to keep it on 100. So please stick with us. And if you're watching this and you're learning anything, share with your friends, share with your colleagues. We got you. But we have to know that you got us. If not, there's no motivation to record more episodes. So
Yeah.
come through for us. Watch this, comment, subscribe, share, and let us know what you think.
Thank you. Yeah, thank you very much, guys, for listening to today's episode. You can check us out on YouTube. There's a podcast on also on
Mm-hmm.
Spotify. So please listen, comment, share your stories. If you have other stories of your pipeline breaking mysteriously, please share your stories. We would love to listen to them and also share with our audience. Thank you very much for today's episode. See you guys in the next episode. Bye.
Bye.